everyone, today I'm going to go over applying properties of real numbers. This is chapter 1, section 1 from the Algebra 2 textbook. So first we're going to define what a real number is. A real number is any rational or irrational number. So within the rational numbers, there are three different subcategories. So there are natural numbers. Those are also called the counting numbers. So when you count, you start with 1, 2, 3, 4, and then you can keep going up. Then for whole numbers, these start with 0. So 0, 1, 2, 3, 4, etc. And then for integers, so this will also include negative numbers. So -3, -2, -1, 0, 1, 2, 3, and you can keep going in both directions. And then the biggest category for rational numbers is any number that can be written as a fraction. So for example, 1/2, 3/4, 0.8, any of these would be considered rational. Then over on the irrational side, these are numbers that cannot be written as a fraction. So for example, there's pi, which cannot be written as a decimal, and it's not repeating. Square root of 2, square root of 5, anything like that. So the first section is graphing real numbers on a number line. So let's say we have the numbers -0.2, 7/12, -3, square root of 3, and -2.5. So first I would figure out what the square root of 3 is. So this is going to be about 1.732. And then on my number line, I'm going to start at -3. And figure out where the points would be. So -0.2 would be a little less than 0, so it would be like somewhere here. And then 7/12, that's a little less than 1, so somewhere here. The next number is -3, so that would be right on the -3. Square root of 3 is about 1.732, so that would be a little more than halfway between 1 and 2. And the last number, -2.5, that would be between -2 and -3. So that's how you would graph real numbers on a number line. I'll do another example. So let's say we have -0.15, 4.2, square root of 5, -3/4, and -1. So first I would label out my number line. Since my smallest number is -1, I can start at -1 here. Because I know that I have to include 5 since we have 4.2 and that's between 4 and 5. So first we have to figure out what square root of 5 is. This is about 2.236. -1.5, that is between 0 and -1, and it's only a little less than 0, so it'd be somewhere here. 4.2 would be between 4 and 5 and closer to 4. Square root of 5 is 2.236, so between 2 and 3, a little closer to 2. Next one is negative 3 over 4. So that would be between 0 and negative 1 and closer to negative 1. I'll just draw an arrow. So negative 3 over 4. And then the last one is negative 1. So that's right on negative 1. Next, we have properties of addition and multiplication. So the first property is closure, which means that if a and b are real numbers and you're adding or multiplying them, the product or the sum will also be a real number. So like 2 plus 5 is 7, which is all real numbers, and 2 times 5 is 10, which is also a real number. Commutative, how I remember this is change order. So a plus b equals b plus a. All you're doing is flipping the order of how you're adding them. And same with multiplying. A times b equals b times a. So that's how I remember it from the first two letters here. And then associative is when you move the parentheses. So in the first one, they have it around a and b, and then they move the parentheses to be around b and c instead. Identity is when you get the number that you started with. So for addition, you have to add 0 to get the number that you started with, and for multiplication, you multiply by 1 to get the number that you started with. And then the inverse is how to get a 0 or 1. So for addition, the inverse of adding is subtracting, right? So we would want to add the negative of the original number to get 0. And for multiplication, the inverse would be division. So we want to multiply by the reciprocal, which is 1 over a. And then you'll get 1. Then for distributive, you would distribute the number or letter in the front to both terms, and then you'll multiply. So a times b plus a times c. So the opposite, which is the additive inverse, so that just means if you have a positive number, the opposite would be a negative. And the reciprocal is the multiplicative inverse. So the reciprocal of a would be 1 over a. You're kind of just like flipping the fraction. So let's do some examples using what we just went over. So if we have 12 times 4 divided by x equal to 48 divided by x. You want to prove that this is true, and you want to use the properties and the vocabulary that we just went over. So first I noticed that they still have the divided by x part, which is this part, so that means they didn't change this at all. All they changed was they multiplied 12 times 4. So in order to do that, they moved the parentheses to 12 times 4 divided by x. So since we moved the parentheses, this is the associative property. Okay, next, if we have 6x plus 5 plus, okay, plus 5 plus 3x equals 9x plus 5. So in this one, they left the 5 alone. And they have 5 on the end instead of in the middle like the original problem. So what we can do is switch the order of these first so that 5 is at the end. So for this step, since we're changing the order, this is the commutative property. And just like the last one, we can't combine 3x and 5, so we're going to move the parentheses to 6x and 3x. And then the plus 5 will be on the outside. So since we're moving the parentheses, this is the associative property. Okay, let's do one more of these. So if we have x plus 4 minus 4 equals x. So again, x is still left in the problem. So that means I'll want to move the parentheses. So x plus 4 minus 4 equals x. So here, 4 minus 4, these are opposites. So that means that this is also the inverse. And we know that that equals 0. So x plus 0 equals x, and this is the identity property. Oh, I spelled that wrong. Identity. Alright, next are the word problems. Everyone's favorite. Okay, so you work 5 hours and earn $65. What is your earning rate? So when you work anywhere, you want to know how much you make per hour. So we're really looking for dollars per hour. So that means on the top of our equation will be the dollar amount, which is 65 in this problem. And on the denominator would be the total number of hours. So this is 5 hours. So 65 divided by 5 is $13 per hour. Okay, next one. How long does it take to travel 200 miles at 50 miles per hour? So since it's asking about like the length of time, they're looking for the number of hours. So we have 200 miles, and then it says 50 miles per hour. So we can rewrite this as 50 miles per hour. And because it's a rate, you can actually flip it so that the units will cancel out. So since we started with 200 miles, we want miles on the denominator so that miles will cancel out. And then on the top would be the time, which is hours. So right here, miles will cancel out. So we really are doing 200 divided by 50, which is 4. So the answer would be 4 hours. Alright, the last one, you drive 40 miles per hour. What is your speed in feet per second? So this one, we want to convert both miles and hours into feet and seconds. Oops, let me use blue. Okay, so this is 40 miles per hour. So let's switch hours to second first because that's kind of easier. So in 1 hour, I'm going to have this on the top because I want it to cancel out with the hour on the bottom of our original problem, is 60 minutes. But we don't want it to be in minutes, we want it to be in seconds. So we want to convert minutes to seconds, and 1 minute is 60 seconds. And here the minutes will cancel out. So we're done with converting hours to seconds, and seconds is in the denominator, which is what we want. So now we have to convert miles to feet. So 1 mile is 5,280 feet. I had to look this up. Okay, so then the miles will cancel out with the miles here. And if you look at our units that are left that aren't crossed out, we have feet per second. Okay, so to solve this, you're going to multiply all the numbers on the top. So kind of like when you're just multiplying fractions, you would multiply everything in the numerator. So 40 times 1 times 1 times 500, or sorry, 5,280. And on the bottom, you're going to do the same thing. So here's 1 hour. So 1 times 60 times 60 times 1. So that's just 60 times 60. And once you plug that into a calculator, you'll get 58.6 feet per second. And then this would be the final answer. Thank you so much for watching. I hope this video helped you understand this section of Algebra 2. If you have any questions, feel free to message me or leave a comment in the comments down below. Bye!